All right, ladies and gentlemen, last week we focused on, actually the last 2 weeks, we focused on the rules of exponents. One of the places that you're going to see the rules of exponents used is in what we call scientific notation. And I'm going to guess that you have seen this before. Scientific notation looks like this. You have a number, like a constant, times 10 to a power. Here, 5.74 times 10 to a power. So scientific notation allows us to write really big numbers, like 42,590,000, or really small numbers like 0.0000574 without all the additional zeros and spaces. So we kind of condense it down. So if you're looking at something like this first one, the rule with scientific notation is that you're going to have a constant times 10 to a power, but that constant has to be between 1, which it can equal 1, but it has to be less than 10. It can only be one digit. So you have, in this case, you have to place the decimal so that there will only be one digit to the left. So in my case, in this first example, that's why they chose the 4 and then put the decimal, because 4 is a constant between 1 and 10, and it's only one digit. So the location of the decimal for scientific notation is going to be here. Then I write the rest of the digits, but I do not write the zeros, because that's the whole idea, is to get rid of some of these extra spaces. But ultimately, you need the number to have the same value. So 4.259 is not the same as 42,590,000. So you have to incorporate this second part that tells you how many times did you multiply by 10, meaning how many spaces did the decimal move, because every time you multiply by 10, it moves 1 over. So to have the number be what I started with, if I'm putting the decimal between the 4 and the 2, it has to go to the right 1, 2, 3, 4, 5, 6, 7 places. That's where the 7 came from. In the second example, the place you would have to put the decimal is right there where the arrow is pointing between the 5 and the 7.4, because then the 5 is my constant, which is between 1 and 10, and then all the other numbers go after it. But again, I eliminate the zeros because I'm trying to get rid of that extra space that it's taking up. So here the trick is, if the decimal is located in this spot, that is actually going to eliminate 1, 2, 3, 4, 5 spaces to the left. So that's why my 5 in this case is negative, because I eliminated spaces to the left instead of eliminating the spaces to the right like I did above. So a positive power is going to ultimately mean that your number will end up really big because you're moving to the right and adding spots to the right. A negative power, like in this example, will ultimately mean that your value is going to get very small and be a decimal because you're moving or eliminating elements to the left. So this is just the opposite direction. Here they're giving us the scientific notation form and asking us to write it out. Well, this one in a lot of ways is easier. I have my 2, I have my decimal, and then this is telling me, because it's positive, I'm going to move from that spot 6 to the right. So that's what they did to come up with their final answer, was they moved 1, 2, 3, 4, 5, 6, and because they needed 2 more spaces, they filled those spaces with these zeros. In B, I again have my scientific notation, but this is a negative, so I must have eliminated spaces to the left. So I'm going to go to the left when I expand it back out. So from this spot, I go 1, 2, 3, 4 to the left. The 1 fills the first space, but I'm going to need 3 zeros to fill the rest of the spaces, which is why in this final answer, there are 3 zeros and then the 1685. So let's try this on our own. Write in scientific notation. So in the end, I should have a constant times 10 to a power. Okay, so currently my decimal is here. I need to have one digit to the left. That's between 1 and 10, so I'll need to do that. But in order to put it here instead, and then I look back at my original number, I think, okay, well, that would require me to move it 1 to the left. And so when I go to do this, I would go 10 to the negative 1, because to get back to my original number, I have to move the decimal place to the left 1. So again, kind of keep in mind when you start with a decimal, like a really small number, you're going to end up with a negative power. And when you have a really large number, you'll end up with a positive power. Now here, I do have a decimal, but I actually am going to have to move my decimal point over here to make it be in scientific notation. Okay, well, looking back at what I had, in order for this 8.24 to have the same value as 82.4, I'm going to need to ultimately scoot that to the right. So I'm going to need a 10 to the positive 1, because you're saying if I take 8.24 times 10, I'll end up with 82.4, which is exactly what I had. Here, I'm going to be eliminating all these zeros off to the right. So I'm expecting to have a positive power, because I'm going to place the decimal here, but it really belongs 1, 2, 3, 4, 5, 6, 7 spots to the right. So I'll have 10 to the positive 7. Here I can see I have a small decimal, and I'm going to be putting my decimal over here. So I'll have my 4.06. That way I have my one number in front of the decimal, my one digit. But to make it look like it used to, I would have to go 1, 2, 3 to the left. So I end up with 10 to the negative 3. Wowza. Okay, I'm going to be eliminating a lot of things to the right. My initial value is 9.0. That's where I have to put my decimal in order to have one digit to the left that's between 1 and 10. But then I look and I say, okay, but to have 9 equal the number it started off as, I'm going to have to move over to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spots to the right. So I would write times 10 to the 14 power. How about here? Well, my decimal is going to go way over here, and I'm going to be eliminating things to the left. So I already know my power will be negative. So I keep the 7 all the way through to the 8 because I don't want to lose the 8. So I need those zeros in between there. But then I look back and I think, okay, that's where I'm putting the decimal for scientific notation, but it's supposed to be here, which is how far away? 1, 2, 3, 4, 5, 6, 7, 8 spots to the left. So I would have 10 to the negative 8 power. Now we're going to be doing the opposite. They're giving us scientific notation, and we're going to write it in standard form, which is like normal numbers. This is a 3 and it's positive, so I'm going to be moving my decimal space 3 to the right. So I'm starting off with 2.6 times 10 to the 3. I'm going to need to move my decimal spot over 1, 2, 3, and then I'm going to add in zeros. So I end up with 2, 6, 0, 0, and I would put my comma where it belongs. Here, negative 10 means I'm going to be moving my decimal to the left 10. So I have 6.411, but I'm going to move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and move my decimal there. And then fill all these spots with zeros, and I have 9 zeros because the 6 was filling up that first of the 10 spots. So this scientific notation number is the same as this decimal in standard form. Think about this one. Will you be moving to the right or left with a power of positive 2? You will move to the right. So 1.11 times 10 to the second is going to move my decimal place 2 to the right, which actually just puts it at the end. And I don't have to write the decimal at the end of a number. There's no place else to go. So 111 is my final answer. And in the last one, because this is a -6, think about which direction you will be moving the decimal point. You're going to be moving that to the left. Okay, so hang on, I'm just looking up what our assignment is that goes with this so I can tell you here when I'm done. I had it on my computer, but it decided to go away. So let's find out. We are going to do, okay, so first of all, let's finish this guy. 1.2034, and I'll be moving 6 to the left. The first space is filled with my 1, then I'll need 1, 2, 3, 4, 5 more to have gone 6 spaces. So those 5 extra spaces get filled in with zeros. So 0.0000120034 is the standard form version of this scientific notation number. Okay, so you are going to be in IXL and you are going to complete G1 to a SMART score of 80, but like always, if you get higher than 80, that will count as extra credit. Since today is Monday, let's try to get that one done by Wednesday at 10 p.m. because I don't want you to get too far behind for the week. Alrighty, have a great day. Keep in mind that if this video didn't help you enough, you can always Google for other videos using Khan Academy or any other way you can to make sure you feel confident before you start your homework. Have a good night, you guys. Bye.